Hello, everyone, and welcome back. So, we've been exploring machine learning so far. We've dived into some classification algorithms such as support vector machine, k nearest neighbor algorithm, logistic regression, and naive Bayes. Now, it's time to turn our attention to regression algorithms. Today, let's delve into something sweet ice cream sales. Mmm. So, imagine predicting profits on scorchy summer days. It's not just a dream, we are making it a reality using linear regression. In this video, we will analyze ice cream sales and temperature data. We will uncover the relationship between temperature and sales and predict profits accurately. So grab your ice cream while we start. In this video, we'll be using the temperature and ice cream sales dataset from Kaggle. I will leave the link down below. You can just come here and download it, okay? Once you download it, kindly place it in the same working directory as your Jupyter file. And once you are done with these setups, let's get started. Alright, so let's start. So we have 7 steps, and the first one is to import the necessary libraries. So I'm just going to import them, okay? And I'm going to run them. And the next thing we are supposed to do is load our data set. So I'm going to create a variable called data, and I'm going to use the pandas.read CSV, okay? And we are supposed to provide the name of our data set. So I'm just going to go back here and copy that, okay? So I'm just going to copy the data set right here, and I'm going to paste it here and run it, okay? Now we can visualize our data. I'm going to create a cell below and say data.info, okay? So now let's visualize our data. As you see, we have 365 entries and we have two columns, right? We have the temperature column and the ice cream profits. We have 365 non-null counts for both of them, which means our data set is full, okay? We don't have any missing data values. And we have int and also float as our data type for the columns. We can also visualize it through scatter plots, okay? All right, so I have the code here and let me run it. Okay, so looking at our scatter plot here, what or the information we can get from it is whilst the temperature increases, our profit also increases, right? So there is some linearity between the two columns or the two variables. So now we can go ahead and then also split our data. So first we are supposed to split it into features and labels, okay? Or dependent variables and independent variables. And I'm just going to do that by saying data dot drop, okay? And here we are supposed to pass in okay, let me create a new. I just want to get the columns names right, okay? So you're supposed to drop profits. So ice cream profits. So I'll come here and then ice cream profits and say axis cross one. Okay. And down here we are just going to call it right here. So here we are dropping the ice cream profit from the data set, and the remaining, which is the temperature, will be stored here. So our temperature is our feature and our label is our ice cream profits, okay? So I'm just going to run this and let's take a look at it. So x, all right, so x is our temperature, right? And let's take a look at our y, which is our label, right? So now the next thing to do is to split our data into training and testing. So I'm just going to say train, comma, x underscore test, okay? And y train and y test. Oops, y test, okay? And we are going to call our train test split. So I'll just call it here And what you are supposed to do is we are supposed to pass in our y and our x. And we are supposed to pass in the test size, which is zero point 0.2, and the random state, oops, which is 42. Okay. So what you are basically doing here is we are splitting our data into training and testing. And for the testing, we want 20%, okay, and 80% for training. So I'm just going to run this, okay, and we can take a look at our training. So X train. So we have 292 for training, okay, and the remaining will be for testing. So let's quickly now move on to initializing our model and also training it, okay. So we are going to create a variable called log- linear regression model, and here we are going to call our linear regression, or yeah, so we will call this, we're going to call it right here, and we are going to train it, okay. So I'm just going to call the model here and call the fit, and I'm going to pass in my x train and y train, okay. So x train and y train right here, okay, and I'm going to run it, okay. So the next thing we are supposed to do is make predictions, and we will now have to call our model again, and we will now call predict method on it, and we are supposed to pass in our x test. So I'm just going to pass in our x test here, okay. So these are the values, or they are predicted values, right? We can now store this in a variable. So I'm just going to store it in y predict, okay. And now we can use that to evaluate our model, okay. So we can evaluate the model using our mean square or our R2, okay. So the one we imported here. So we are going to use these two to evaluate our model. So I'm just going to copy the two and bring them down here, okay. So the first thing we are supposed to do is create a variable for mean square, okay, and we are going to call this right here, and we are supposed to pass in our y test, which is our actual value. So I'm going to pass it here, and I'm also going to pass the predicted. Good. So, and then we also supposed to check our R2, okay, so which is our score. That one too, I'm just going to call the method again. So just paste this right here, and that one too, I'm just going to do the same thing. So I'm just going to copy these two and paste them right here and delete this thing, okay. All right, so this and let's create some print statement here, just to, and I'm just going to say mean square error, okay. And with this one, I'm just going to give it this one, okay. So this mean square error. I'm going to pass it right here, and down here I'm just going to print the R2, okay, which is our R square score, okay. Yeah, so with this one too, we will pass the R2 here, okay. And now once you run it, okay, so our root mean square error is 5.2, okay. So the best you can get is 0, so it has to approach 0. And our r squared, which is like in classification we say accuracy, okay. So with that, our score is 98%, okay, which is 0.983, okay. So that is 98%, 98.3%, right? So it means our model is kind of performing well, right? And the next step is, sorry, not evaluation of the model, but here we are just supposed to save the model. Okay. And we can do that with the dump. Okay, so I'm just going to call the dump here. Right here. Okay. And what I'm supposed to do is call the model. So the name of our model is RLR. So I'll paste it and then the file name. So let me say I want it to be saved this way. So looking at our data set, we have only three items here, right? So now let's save our data and see what happens. Okay. So now we have our model being saved in our working directory. Okay. So we've been able to implement our linear regression within or in just 7 steps, right? I hope this video really enjoyed it. If you did, kindly click on the subscribe button, like this video, share with friends, and watch out for the next one. See you in another video.